Okay, so today we're going to talk about the law of sines. And people find this one a little bit easier, I think, than some of the others. But we're going to start by looking at where it comes from. I'm just going to draw some generic triangle. My generic triangles a lot of times end up looking very similar, but so they look a little maybe acute. I usually draw an acute one, and I usually draw one that looks not too scalene, right? The sides are very similar, but it doesn't matter what triangle you draw. Any triangle that you draw is going to work. Even an obtuse triangle, any triangle that you draw is going to work. Now, up until now, we've only dealt with right triangles in trigonometry, right? So that's why I'm going to draw down this altitude, because we're going to talk about this using the trig that we know, okay? So the first thing I'll do is label these sides, I guess. So we'll call this one AB and this side C, this whole side C. That would make this angle B, this would be angle A, and this will be angle C. So I'll just label the sides of the triangle first, okay? And we'll call this one height, I guess. H for height, you can call it whatever you want, it doesn't matter, but I will call it H, okay? Now, if I draw it this way, of course you know that if that is really the altitude, if that really is the height, then it's at a right angle with the base of the triangle. And I'm just choosing to call this side the base. I could flip my triangle and call this side the base. It doesn't matter which side is the base of a triangle. It doesn't even have to be the one on the bottom, right? I could draw it this way and make this the base. I could just draw the altitude the other way. Okay? So what can we say trigonometrically speaking, right? We could say that if I take this angle here, I could say that sine A is equal to the opposite over the hypotenuse. That's something I could definitely say, right? And everybody, I think, would have to agree with me. So it would be H over B. I could also say, I suppose, that if we're looking at angle B here, I could say that sine B is equal to H over A. And if I multiplied both sides by A, I'd have something that looks like that. And if I multiply both sides by B on this one, and clearly we can see that in this triangle, this H and this H are the same, because obviously it's the same exact side. So on this triangle, the height and the height are the same thing, right? So what could we say here? Since these two things are the same, I could use my transitive property and say that those two things also have to be the same. Right? If two things are equal to the same thing, then they're equal to each other. All right, here's the last thing I'm going to do to make it look like our law of sines, that if any of you have seen the law of sines, you know what it kind of looks like. I'm going to divide both sides by this B and this A, or AB is probably what you wrote, because mostly times we write them in alphabetical order, but makes no difference. And then here, I'm going to divide the B's, that will give me a 1. I'm going to divide these A's, and that will give me a 1. So they sort of cancel out, sometimes we say. And this one says sine A over A is equal to sine B over B. And this is the basically our law of sines. There's one piece of information missing. And you can actually get that piece of information by drawing an altitude across one of these other ones, right? And making the angles like this. So like if you hold your triangle this way, you can say that sine C is equal to H over B. And now you can say sine B is equal to H over C. And do that same process again, right? And what are you going to end up with? You're going to end up with sine C over C is equal to sine B over B. And again, if these two things are equal, and this thing is equal to this one, then they all have to be equal to one another. So we can just throw in here that sine C is over C is also true, okay? And this is our law of sines. And basically, that's all there